Hello everyone, today I will be explaining 5 technical questions from the CCNA exam. Let's start with the first question. The first question comes with a diagram. Let's see what it means. I'll copy it out here. It says the engineer, this diagram is a bit small, but that's okay. It says that the engineer has deployed a topology in which device 21 needs to obtain an IP address from the DHCP server. Now, if the DHCP service configuration on the switch in the middle is correct, in other words, the switch in the middle is actually transparent and has no configuration, then we must use 2 commands on 2.1 and 2.2 to allow 2.1 to obtain an address. The correct answers are B and C. This is a multiple choice question, so you need to select 2 options. B and C. Let's look at B first. On device 2-2, we need to enter the G00 interface, that is the internal interface, and configure the IP address 198.51.100.100 on it. Why is that? First of all, this DHCP setup uses a client-server CS architecture, right? It's a client-server, CS architecture, and then the DHCP client first sends a discover message. This message is a broadcast message, a broadcast. This broadcast message cannot cross broadcast domains, and the router's interface isolates broadcasts, right? So when this message is sent out, we need to configure a relay service, also known as an intermediary, on the internal interface that receives the discover message so it can help forward it, right? It changes the broadcast message into a unicast message and then forwards it to the server, and that's how the server's address is determined, right? That's it. So option B is correct. Then, for the configuration above, you enter the interface, enter F01, which is the fast Ethernet interface, and assign it an IP address via DHCP, right? This means it will use DHCP to request an IP address, so it will send out a discover message. But before sending it, of course, we need to enable this interface, right? No shutdown is used to enable these interfaces, so the correct answers are B and C. Let's take a moment to carefully look at the correct answers. They are indeed B and C, which are the right choices. All right, next question. The second question is also a multiple choice question. If you want to learn Cisco technologies or get access to Cisco question banks, feel free to send me a private message or leave a comment below the video to discuss technical topics. For this question, we also need to select 2 answers. Now, this question is a bit difficult. It's about early random detection, specifically weighted early random detection mechanism. So, what exactly is this particular mechanism? This mechanism is an integral part of what is commonly referred to as QoS, or Quality of Service Management. Within the broader framework of QoS, it specifically functions as a crucial congestion management technology. For instance, consider a scenario where my router's gateway interface possesses a maximum bandwidth capacity of 1 gigabit per second, but there is a substantial volume of 5 gigabits per second of network traffic converging from various downstream sources. In such a situation, it becomes quite evident that a significant number of data packets will inevitably be dropped at this point, correct? So here, I set up a queue for them to determine whose packets get dropped first and whose get dropped later, right? Whose packets need to be retransmitted, basically to reduce packet loss and allow the packets to be sent out in an orderly and proper manner, right? If we don't use this weighting and just use early detection with random dropping, then it's simply first in, first out. The packets that arrive first are sent first, and those that come later are just dropped directly, right? There's no way to guarantee the forwarding of important traffic. That's precisely why we absolutely need to carefully apply appropriate weighting. The fundamental concept of weighting here is that it can, first and foremost, significantly help to effectively alleviate congestion at the critical interface, right? This is a crucial aspect to consider. The second fundamental concept is that we can effectively ensure that high-priority data packets are dropped at a much later stage, while conversely, low-priority data packets are dropped significantly earlier in the process. In other words, the statistical probability of dropping low-priority packets is considerably higher, and high-priority packets are only dropped at the very absolute end of the queue. Isn't that correct? Not exactly at the very end, but rather the timing of when we drop packets is different. For example, you start dropping your first packet only after I've already dropped 5, right? So there is a certain privilege here, but it doesn't mean that high-priority packets are always forwarded without being dropped. Yes, indeed, the correct answers for this particular question are definitively D and E. To reiterate, the correct choices are D and E. Moving on now, let's proceed to question number 3. This third question is specifically focused on the topic of network address translation, commonly known as NAT. In fact, this question, despite its technical subject matter, is actually quite straightforward and relatively simple to comprehend and answer. This is a question we've already covered in class, specifically within the NA course. It's about a particular technique we've previously discussed. It asks, after the network engineer has successfully configured NAT and meticulously verified that the configuration is indeed correct, when NAT actually occurs, what does the source IP address get changed to? For example, with the Internet Control Message Protocol, or ICMP, in the echo request message of an ICMP packet during a comprehensive ping test, whether you choose to utilize the standard ping utility or some other equivalent diagnostic tool, regardless, for the vast majority of normal network traffic, you absolutely need to have proper encapsulation in place, correct? You encapsulate your source IP and also a destination IP, right? Then it's all completely encapsulated inside. Now, after this particular IP packet goes through the network address translation, NAT process, its original address will be translated from your internal inside interface to the external outside interface IP address, right? In other words, what is it translated to? It's translated to the IP address 72.23.103.10. Isn't that correct? So, therefore, the absolutely correct answer in this particular scenario is indeed C. All right, question 4. Okay, question 4 is specifically about the fixed and predetermined levels of the system log. These levels are crucial for understanding the severity and importance of various system events and messages. That is, the notifications sent by the system log server. What are these notifications? These notifications indicate what has happened, and these are also fixed values. There is a list, a table, with corresponding relationships, and you just need to choose according to these fixed correspondences. If it sends this, it means that the router or router instance has encountered an overlapping situation, right? The correct answer is C. Let's look at the correct answer. Choose C. All right, question 5. For question 5, it says that NTP is configured on a single network to connect to a trusted server. This is a multiple choice question. When connecting to a trusted server in client mode, that is, connecting to a trusted server as a client, which 2 tasks must be performed? The first task, since it's trusted, I must perform authentication, right? That is authentication. Only when both sides are authenticated can it be considered trusted. Then the second task is that I need to specify the NTP server. I need to know where it is, right? Specify its IP address, right? The correct answers are A and C. Let's check the correct answers. A and C. All right, submit. If you want to learn Cisco technologies or get access to Cisco question banks, please send me a private message, or you can leave a comment below the video for technical discussions.